Hello everyone and welcome. Today we are going to talk about quantum computers and is the usability of quantum computers a tall tale or the fact that the near future? Let's start with these basic questions to understand the quantum computers better. Quantum is a term that means quantity in Latin. According to modern scientific understanding, it's defined as the smallest possible unit, energy or matter. Another question is, what is the binary system? Binary numbers are obtained by writing the numbers base of 2. Therefore, all numbers are expressed using the numbers zeros and ones. Due to its easy to applying electronic circuits, they are used in almost all of today's computers. What's the quantum computers in a shorthand? It's hard to explain in a shorthand, but I will try. Quantum computers are machines that use the properties of quantum physics to store data and perform computations. The other issue I want to talk about is quantum computers will speed up database searching. But why? Because today's binary computers searching one-to-one. So, traditional computers, which binary computers, can be at only one place simultaneously. But quantum computers can be everywhere at the same time. Are there any quantum computers? No. IBM is an experienced company in quantum computers and has made significant progress, but it's not alone in this area. Big companies such as Google and Intel that develop their own quantum computers, as well as companies like San Francisco-based Rigetti, who want to revolutionize the field, are also IBM's rivals. Along with these companies, Canadian quantum computer company D-Wave has developed two quantum computers currently used by Google and NASA. Okay, but how is it working? Classical computers, which include smartphones and laptops, encode information in binary bits that can either be zeros and ones. In a quantum computer, the basic unit of memory is a quantum bit or qubit. A series of qubits can represent different things simultaneously. For example, a classical computer can represent any number between 0 and 2055 with only 8 bits. However, an 8 qubit will simultaneously represent all the numbers between 0 and 255. A 500 qubits would be enough to represent more numbers than all the atoms in the universe. It's important. For now, quantum computers are highly sensitive. Heat, electromagnetic fields, and collisions with air molecules can cause a qubit to lose its quantum properties. This process, known as quantum decoherence, causes the system to crash, and it happens more quickly the more particles that are involved. So, what is a qubit? Quantum computing uses the qubit is the basic unit of information rather than conventional bit. The main characteristic of this alternative system is that it permits the coherent superposition of ones and zeros, the digits of the binary system around which all computing revolves. Bits, on the other hand, can only have one value at the same time, either 1 or 0. This aspect of quantum technology means that a qubit can be both 0 and 1 at the same time, and in the different proportions. This multiplicity of states makes it possible for a quantum computer with just 30 qubits, for example, to perform 10 billion floating point operations per second, which is about hundreds of millions more than the most powerful computer on the market. So, is a quantum computer a dream? This is our original topic actually. In my opinion, it's not a tall tale. So there are several quantum computers already. But when we say or think about quantum computers, bigger things come to our mind than we do now. Actually, searchings and developments indicate that quantum computers are going to be so effective in a short time. What do mathematicians think about it? Not everybody is convinced that the quantum computers are worth the effort. Some mathematicians believe there are obstacles that are practically impossible to overcome. Thank you for listening to me. Goodbye.